submission. Some of the functional niceties of Teredo include that it works through NATs and with hosts possessing no public addresses. Does automatic tunnel setup. The Teredo client is provided with a global address and is globally addressable. No support is needed from the local network. That's because there's public Teredo relays and servers that are being used. The peer IPv6 host need not be aware of Teredo at all. And the local application need not be aware of Teredo at all. So it's all abstracted. It's transparent. Now, why is Teredo often needed for IPv6 connectivity? Well, it's a combination of three reasons. Many of the computers on the internet currently are behind IPv4 NATs, and these IPv4 NATs don't support native IPv6 or even ISATAP. And the fact that NATs, especially home gateways, are rarely upgraded, that means we're stuck with those for a while. So that's a major barrier to having IPv6, at least in some people's views. However, the specification does say that Teredo should only be used when IPv6 and ISATAP aren't available. That's because Teredo is less efficient and it's less reliable. It won't always work. I guess you could say that in general for IPv6 transition mechanisms, but I think especially with Teredo. And the phrase they use is that it should be an IPv6 provider of last resort. Okay, Teredo is enabled by default in Windows Vista, and it is the IPv6 provider of last resort. It's not clear if it'll always be. There may be some cases where Teredo is preferred over native IPv4. You got the tunneled version rather than just straight. And Microsoft hasn't really clearly documented this. So the safest thing to assume is that Teredo will often be in use on just an arbitrary Vista host. So in fact, we did see it used more frequently than Microsoft's documentation suggested, at least what the documentation initially suggested. So there's some ambiguity there. It'd be nice if Microsoft clarified the documentation, made it more clear. Teredo is also available on Windows XP and Windows Server 2003, although it is disabled by default. Okay, now I'll go into sort of how Teredo works. There's this Teredo component called a Teredo server. I'd like to say that they're the client's helpful friends with the right connections. It's always nice to have those kind of friends, right? In this case, they have these native that these Teredo servers have. In addition to having IPv4 access, they also have native IPv6 access. So that they can help out in that way. The Teredo servers can help the client set up its address, the Teredo address, and the server, among other things, the server will report back to the client what its external IP address and port is. It also helps the client determine if the NAT that it has is compatible with Teredo. Many are, some aren't. In fact, Microsoft's implementation does some things beyond what the RFC says in order to try to support these other NATs. And Microsoft hasn't documented exactly what they do. The server for the client to use is generally statically configured on the host. That's the only part of Teredo that's not entirely automatic. And for Vista out of the box, it uses some Microsoft servers that Microsoft decided to support Teredo. They just wanted to stand up some servers to help. Teredo addresses are IPv6 addresses. Whenever you see an IP address of 2001.0.0.0.0, that's a Teredo address. I'm not going to go into the format in any detail, just in the interest of time. But these addresses are unique, and they are global scope, which means they're globally routable. Okay, just to sort of give an overview of how Teredo looks on the network as it goes across the internet. Over here on the right side, where the single arrows, that's where the IPv6 is native, just a pure IPv6. Although on the left side here, the double arrows, that's where IPv6 is being tunneled over UDP, over IPv4. Looking like this. Here's the real IPv6 content, and it's being included in an IPv4 and UDP header. And optionally, sometimes there'll be 1 or 2 layers of Teredo data in between there. So that's what it looks like over on this side. These relays are here to do to interpret things the other way. When going in this direction, if I could draw an arrow there, it'll decapsulate the packet. It'll take it out of its IPv4 wrapper, and when it's going the other direction, it'll encapsulate it. And the way the relay can do that is actually kind of clever. Is that the Teredo address has enough information for the relay to know how to address the client via IPv4. It has the destination address and the destination port included in the address. Just because the IPv6 address is so much larger than the IPv4 address. And either the peers or the clients can initiate a packet send. It's pretty easy for the peer because it doesn't know anything about Teredo. It just needs to address something to 2001.0.0.0, whatever the address is. And when it gets to the relay will encapsulate it and send it along. And the way it finds the relay is that the relay is advertising a route to 2001.0.0.0. So just the normal IPv6 routing mechanisms take care of the routing. Now it's a little more work for the client. That's because it needs to find out what relay to use to reach a specific peer. So it gets some help from the server for this in what I call the ping test. Okay. How this ping test works is that the client creates an echo request destined for the peer, an IPv6 ping, and where the payload is a random number that it produces. The client will encapsulate this and it addresses to the IPv4 address of the server. When the server gets this, it'll decapsulate it and just drop it on the IPv6 internet. At this point, it's just a normal IPv6 packet. So that when the peer gets it, it'll respond to the ping, assuming it does respond to pings, and they'll get routed back to the Teredo relay. The Teredo relay will encapsulate it and pass it along to the client, and the client will verify that the payload matches. The payload is what they call the nonce. That's just to avoid spoofing. And the client will also remember that the IPv4 address and UDP port as the relay to use for that peer. And also, it's also only supposed to accept packets purporting to be from that peer if it came through that relay, or at least appeared to come through that relay. Now, you may notice a problem there in that some NATs don't accept packets inbound unless it's a recent outbound destination. But I'd say that's a sensible thing for NATs to do. So that the relay needs to work around this somehow. And Teredo does have a provision for doing this. That is so it can actually get past here. And that works through what they call using a bubble packet, which is just an empty IPv6 packet. The Teredo relay will address it such that it'll send it to the server, asking the server to pass it along to the client, and asking the client then to go back to the relay. Simple, right? So by doing that, the relay becomes a recent destination of the NAT, and then at that point, the relay can just directly send packets in. Just basically bypassing the NAT's restriction. And the server is always maintained as a recent outbound destination. Okay, now we'll go into some of the security implications of Teredo. Teredo does raise a number of security concerns, some of them serious, including unexpected host accessibility, the network security control bypass, the cost to locate the Teredo IPv6 payload, pure address disclosure, phishing and farming with Teredo. And there's several more that are beyond the scope of this talk that are in the paper on your CD. Teredo also does provide a few security positives. I'll grant that. And some of these concerns aren't mentioned in the RFC, Teredo's RFC. Because of this, I submitted a internet draft to the IETF to document our concerns. Now, this draft is now being maintained by Suresh Krishnan, and as of a couple of days ago, it has been taken up as a V6 operations working group internet draft. That's good. At least people are becoming aware of the Teredo security problems. There wasn't really much documented before I started looking at this. One of the major concerns is that Teredo puts hosts directly on the internet, by giving them global addresses, and anybody can send an IPv6 packet directly to the Teredo client, and if the client's maintaining a stable open-ended tunnel. Now, just to be clear, IPv6 connectivity, end-to-end connectivity is the way it is supposed to be with IPv6. In fact, it was supposed to be like that with IPv4 as well. That's why you have global addresses, at least used to in IPv4. However, with IPv6, the administrators would certainly be aware of the exposure. That's because you set up your IPv6 access. Then you obviously think to have your security controls in place. But with Teredo, especially on Vista, where it's enabled by default, I'm certain hosts will be unexpectedly exposed. Even if the administrator thinks so, they're just have a private IPv4 address, they're behind NAT, nothing to worry about, right? No. And other sides with Vista in particular, the Teredo may often be active. The Windows firewall does default deny all inbound Teredo packets, at least after that fix that they did. And Vista does require a IPv6 capable firewall to be registered before it starts up, as I mentioned earlier. Another major concern of ours is that the Teredo's IPv6 content bypasses inspection by network security components.